All right, just a couple more things for today. So sometimes you want the values, the values of a data frame. So here, for example, we've got this this column that has these indexes attached to it. If we just want the values, we can use this .values function and get just those values of that column. Another thing that I'll just cover here quickly is using something called apply and lambda. So lambda is what you do when you're defining a function. So lambda, this is an example here. So lambda x, where we're taking x max minus x min, and this whole thing is stored as f. So this is a function on x where we take the max minus the min, and this g is going to be another function where we get the value counts of x, and value counts is a function that can be applied to a column in a data frame. So from that data frame, we can take the numeric columns and we can get the max minus the min. And so for each of those columns, we'll get the max minus the min. So we're applying that function to those columns, to that data frame. We can't do it to the entire data frame because max minus min doesn't only make sense with numeric columns. Similarly, we can apply, if we wanted to get the value count. So this is for each value, how many times does it appear? So 2, 0, 2, 1, 0, 3, those are the 4 options, and they're sorted by how many times they appear. So the command line score way up here, 2 is the most common value. It appears 6 times. So we see that down here. If we wanted to get value counts for every numeric column, one way we can do that is to use this lambda function. And it will give us the value counts for each of those. If we'd done it this way, it doesn't work because it only works on a single column. Two other things. And value counts, I don't think we've covered yet. Just in general, this is a really handy thing to get a sense of like if most of your values are actually nans, like that will show up, or if most of your values are, it gives you a sense of the distribution of your data. Another thing we can do is we can sort a data frame by index. So here we're going to sort this data frame by index. We say df.sortIndex. Ascending equals true, in place equals false, so this does not overwrite the existing data frame. And although it says index, we can actually, if we say axis equals 1, I believe this should work. It will sort the columns by alphabet as well. Often this is also very common. You want to sort your data frame by the values of a certain column. So let's say we wanted to sort this by score MATLAB. We can say again axis equals 0 because this is a column, not a row. and you can say ascending equals false, so it's going to be descending, so from high to low, and in place is false, so we're not going to overwrite the data frame when we do this. So we can see score MATLAB. Yep. So we've now gone from high to low, sorting our table by this column. So this is a useful function. But we can see that because we did in place equals false, we didn't change df. So we still have the original data frame is as we had it before. Another thing we can do is we covered different ways to control the data types of a data frame. So you can either specify, you can just let them be default, in which case pandas will try to infer what type they are, or you can specify when you import them, or you can change them afterward. And we saw you can do a list comprehension, or there's some other ways. Here we're going to see a way using this, using a dictionary and then this map function. So we can say we're going to convert y to true and n to false, and we're going to use that's a dictionary. We're going to map that dictionary onto this column. So right now we have computer has y or n. We want to change that to a Boolean column where it's true false. So we run this. We can see now that we've converted that column to true false by mapping those y and n values to true and false. And if we look at the data types, it's now a Boolean. Finally, I'm going to convert this one person's score to a nan. So now index 10,000, column, score command. Make sure. Interesting. Okay. I'm seeing score OS on here, but the point of this is that if we have a value that's nan, like this one here, if we then use this function is null, it will say true. So this is a way to check if any of your values are nulls. This doesn't really fit in anywhere, but this can come in handy in certain cases. So there's another function is nan, but is null is a little bit better for a few reasons. So that's just one little add-on there. So we're a little bit over time, so that's good that we covered everything today, and we will come back and do more pandas, not next week, but the week after. There's a lot more to do, but before we get a whole lot deeper in pandas, you'll get a chance to test out some of these skills in the assignment, and then next week we'll do plotting, so we can kind of get to where we're going, which is to take data that we've process and analyze and actually make some graphics to see what's going on. So that is it for today, for this week.